Welcome to The Bootloader. I'm Paul Cutler.
And I'm Todd Kurt, and this is episode 2. The show works like this. Paul and I each have brought 3 things to share with you. We'll spend a few minutes talking about each, but no more than 5. If you want to learn more, we have detailed show notes available at thebootloader.net, and give us a follow on Twitter at thebootloader.
So I wanted to follow up from last week, Todd. You had shared the Full Control XYZ, and they released a new STL last week for a phone holder, and the phone holder is pretty cool in and of itself, that it lets you use it vertically or horizontally. But when you go to the STL, there's a challenge to print it at double speed.
Oh, cool.
Now I've got an Ender 3 V2, and I took the challenge, and it printed out perfectly.
Oh, wow.
I've never printed something out this fast on my printer, and love it. Those guys are doing a great job over there.
That's amazing. What filament did you use? Just standard PLA?
Yep, just standard black PLA. I think it was Arion, so it was pretty cheap stuff.
Oh, that's cool. Yeah, I love that there are different ways you can use that phone holder. It's like this weird sort of organic C shape that the phone goes in at multiple different directions. It's pretty awesome.
Make sure to include some of those in the show notes as well. Before
Definitely.
we get started this week, I did want to give a shout out to everyone who listened. Thank you, thank you, thank you. You made our launch such a success. I also should mention that I was inspired by the Python Bytes podcast hosted by Brian Ockett and Michael Kennedy for the Bootloader. You'll notice that the format is slightly similar, and I also have an interview podcast like Michael Kennedy, and both of them have been so kind and gracious as I've launched both of these podcasts in 2022 that I just wanted to give them a shout out and thank them for all their help.
Yeah, thanks, guys.
Todd, why don't you get us started this week?
All right. So first thing I want to talk about is an LED color pattern language. So if you've followed the Makerverse on Twitter, you may have seen projects by Geek Mom Projects, aka Deborah Ansel, aka Geek Mom Projects. And in her cool LED project, she often uses these PixelBlaze LED controllers. And they're pretty interesting. They're ESP32 based, so you connect to them via Wi-Fi, via your phone or computer or whatever. You configure LEDs, and then you can select from a bunch of different patterns that are built in. And there's a huge online library of existing patterns, of different color patterns. You can just kind of click on and click run, and they show up on your LEDs. But what's really interesting is these patterns are algorithmically defined. There's a little built-in editor that runs in the browser, so on your phone or on your computer, where you edit these patterns. So like anything you download, you can just look at and you can change if you don't like exactly how they work. And then you can run and you do the standard sort of edit, test, run. But instead of a computer language, it's this kind of special JavaScript-y colored language for just LEDs. And it actually is the PixelBlaze DSL domain-specific language actually is a ECMAScript derived sort of mini version of a JavaScript-like language. And it's got a bunch of built-in LED and math functions. So your scripts can be really small. Like if you wanted a simple sort of spinning rainbow animation like the spinning beach ball on macOS, that's like 5 lines because there's like hue functions and, get LED index and all that kind of stuff. So that's one cool thing, the PixelBlaze controllers. You can buy them on Tindy or on Ben Henke's site. They're great. Now, separately, there's these really beautiful Fibonacci LED displays. It's a circular LED display where instead of being arranged like in a grid or in a sort of radial arrangement, they're arranged in a Fibonacci spiral, like a seashell. They're beautiful. They're created by Jason Kuhn, available on Tindy, and he makes a bunch of different sizes of them. But the 40 millimeter one, the size of like a large coin, is perfect for like maybe you're making a wearable pendant. And so the 3 of these people got together and created Lux Lavalier. Lavalier? I don't know how to quite say that word. But it's a wearable LED pendant using one of these 40 millimeter Fibonacci spirals. And it's got a PixelBlaze on the back. And then it's got a really cool magnetic clasp that's also a battery holder designed by Geek Mom. And so it's the 3 of them work together to like create this sort of easy to assemble kit, or it might be fully assembled, but it's like the perfect storm of these 3 makers coming together and making a really cool object. And one of the reason why, even though this is kind of old, like the Fibonacci displays have been around for a couple of years, PixelBlaze has been around for like 3 or 4 years, Geek Mom has been doing LED stuff forever. The website that they've created just for the Lux Lavalier has one of the best intros to the PixelBlaze pattern language that I've seen. And so you can check that out at luxlavalier.com/patterns. We'll have a link to that in the show notes, but it's super awesome.
I love all of their projects. I don't know any JavaScript, but it sounds like it shouldn't be that hard to pick up if it's just a subset of the language.
Yeah, it's like super minimal. So like all the craziness, like a lot of these languages, they get complicated fast, and sort of the same way that Circuit Python is a smaller, simpler version of Python than normal Python. This is an even simpler version of JavaScript than you've ever seen, and so it's really approachable. You don't even have to really understand coding. You just go, oh, I see they're multiplying this number by 5. Well, if I multiply it by 6, oh look, the colors spin faster or something.
And you said that the battery is actually in the necklace?
GeekMom's gotten really good at designing 3D printable structures to hold batteries and stuff and playing with magnets. And it's a thing that holds one of these 18650 magnets. It's like 18650 batteries. And then with embedded magnets on the sides. And so it just kind of clips around. Battery hangs out behind your neck and then the pendants around your chest. Yeah,
well, that's
pretty awesome.
Cool.
All right, so what do you got for us?
My first one is a project called Whisper from the OpenAI group. OpenAI earlier this year released Dall-E, which I think you are a big fan of.
Oh, yes.
So Dall-E, if you don't remember, is you feed it text, it generates the pictures based on the text that you give it. They've taken what they've learned in that machine learning model to the next level, and Whisper is transcription and translation service. So they've released a blog post, a formal paper, and even released a Google Colab with a Jupyter notebook so you can see the code running. But it's a Python library. You do a pip install and then the Git repo for Whisper, and it installs it. Now the catch is for some folks, they might need to install Rust and FFmpeg as well. And I think Rust can be a little tricky at times based on some of the forum posts that I saw. But I got it installed, no problems. And it's this easy to make a transcription. You type Whisper, the name of the audio file that's in your current directory, and it goes. It just works. And it outputs a text file and a VTT file, which are used for subtitles. I originally saw this on Hackaday. It was built with Python 3.9.9 and PyTorch 1.10.1, so they're both, fairly recent versions. I'm glad to see that PyTorch has been transferred from Meta to the Linux Foundation. It gives me a little more confidence to actually use PyTorch.
Totally.
And they've trained it with 680,000 hours, and they created 5 models of that from small to very large. The smaller the model, the faster it runs. And you can pass it command line arguments to tell it which model to run. Now, when you start to think about this, if it's really as easy as typing the command Whisper audio file name, almost anyone might be able to use it. I've played around with a lot of transcriptions because of the podcast. Accessibility is very important. I'll come back to that in a sec. But the irony was this was released just days after I had finished a personal Python project using Assembly AI to create transcripts for the podcast. And I had spent dozens of hours trying to do that because my Python's not very good. And then here comes this that's like, hey, you can do this with one command. Now, there are a couple of catches, but I'll get back to that. So when you think about it, the accessibility part is huge. If you're deaf, you now have the ability to take an audio file and transcript it for free. Most of the services that are out there are paid services, and it does an excellent job. Need subtitles for your YouTube videos? It'll output a VTT file for you. It's not SRT, so that's a catch, but it's good enough. And then the thing that most people really haven't been talking about in a lot of the articles I read was the translation aspect. You just pass it a command line argument, and it will automatically detect which language is being used, no matter what. But then once you pass it the command line argument, it'll take Japanese and translate it to English. There's almost 75 different languages supported with varying degrees of support, and you'll see it on their GitHub page. They have a nice chart that lays it out. But it looks pretty neat. They licensed it MIT, so it's open source. Wow. They've already created a forum for show and tell. People are already building on this. This thing's been out for 2 weeks. I was going to share that one of the things that it doesn't do is speaker diarization. So it can't tell the difference between you and me talking. It's just going to transcribe all of the text from this podcast, for example. Yeah. I was going to call that out as a gotcha. Nope. 1 hour ago, someone actually posted that they built diarization on top of Whisper. So I need to check that out. Someone built a Twitter bot that extracts a video, translates it, and then replies with the translated video on Twitter.
Yeah.
Someone built a command line utility to transcribe or translate audio from live streams in real time. And someone has built a tool that automatically adds subtitles to DaVinci Resolve when you're editing videos, which is pretty
that's
darn
incredible.
cool as well. Pretty amazing, right? The downsides, I was going to say no speaker tagging, but it looks like there might be third-party support for that. And then the only catch that I really saw is it's slow if you're not on a GPU.
Yeah.
So it's about real time if you're not on a GPU, which, it's free.
Yeah. That's incredible. It's just going to get better too. It's like the whole. I remember, in Star Trek, one of the many things that seemed a little implausible to me. One was the universal translator, and granted that this requires a lot of trained backlog of audio, but we're getting close to this real time translation of audio that like we can just have in our pockets or something, or on our wrists. It's just kind of incredible that we can do that. It's something that seems not really real, like it's a thing of sci-fi, not something that we'd actually have in our lives in our lifetimes.
I agree. And in fact, someone actually built a project that transcribes the audio from your speakers live as you play it, which is almost exactly that use case that you talk about. So it's coming. It's probably going to come sooner rather than later. What's your next project?
Kind of related eventually, and I'll show you why. So I want to talk about music generation and live coding, but in the browser. So what do I mean by this? So how does one create music? So the standard way is you write it down, either with a pen and paper or the computer sequencer. It's kind of like the way I do it. But there's another way. What if you had a code window or multiple code windows, and in the code window there was a code block, and the code block had one part of music of the music piece you're creating described in some sort of algorithm. Maybe there's multiple code blocks, and each code block describes different parts of the music you're creating. Maybe they talk to each other. Maybe you have different windows that have different pieces that are sort of interacting with each other. And that seems kind of strange. It's like I'm writing real-time software. I am in real time writing software. It's also real-time software to generate music. And so there's been this thing for a while that's been around called Tidal Cycles. And it is a live coding environment for music. Basically just presents a window, and you start writing functions, and the functions will start playing a melody, and this function will generate a beat, and this function will generate a bass line, say. And they all are synced together, perhaps. So they're all playing with each other. Underneath what Tidal Cycles is it's a Haskell, which is a functional language that's really good at concurrency, shell on top of SuperCollider, which is a audio programming language that's been around since the 90s. A bunch of artists that you might have heard of have been using SuperCollider over the years to make weird sounds. It used to be kind of a compiled thing where you would give it a piece of code and it would generate a sound like a .wav file, and you would listen to it, and you would edit the file and do the sort of edit, compile, test thing that you do with normal code, but the output would be audio instead of a functioning program. But now it's all in real time. And so you have SuperCollider kind of running in real time. Haskell sits on top of it and directs it to create audio in various ways. And that's pretty cool. But it's hard to install. Someone created a thing called Sonic Pi that's also open source. All this is open source, by the way. Sonic Pi is a sort of one-click install app that lets you run something kind of like Tidal Cycles on your computer, but it's still an app. It runs on, in its own little window. But what if you could do this kind of stuff in a browser? And it turns out you can. There's a library called tone.js that is a library that sits on top of the web audio framework that's part of browsers now. And it's not just playing MP3s or waves, but it's actually doing audio synthesis. And so you can create live music generation. Here's a little sample. There's a thing called Strudel that's sort of like a mini version of this Tidal Cycles. And here's a quick little audio piece that's just one line of code. It's a small two sets of arpeggios playing against each other. And now I'm going to edit it. It's just in a browser window on my laptop over here. It's pretty amazing. So even though tone.js and similar thing and Strudel have been around for a while, this was kind of new to me that this was able to be done in real time, sort of doing Tidal Cycles type stuff in the browser. So that was very cool. But there's more.
More?
If you don't tend to want to make music yourself, you can go to pisongs.com, a site created by Canton Becker. And he has used tone.js to make a bunch of little mini sites that algorithmically generate music based on the numbers of pi. So you can create music that no one's ever heard before. And he's got a couple different styles. I just started one up here. It's sort of like finding the random digit of pi I just chose, and then starting up playing. And this is sort of an ambient soundscape generator.
Well, the nice thing about this being unique is that we're not going to get a YouTube strike against us by playing it.
That is exactly what I'm thinking. Is that I could have this play for hours, no one would care. And so there's this one, and it's very nice. It's very kind of mellow, just to have in the background while you're writing software. There's also a techno one. These are the same techniques. This is a different digit of pi, but it will start playing techno. Let's see if it starts up here.
This is good music to code to.
Yeah, exactly. And then, if you really want to go to a rave, there's also acid hit, which will generate random acid techno bass lines. So I think that one was at the 1,600,665,893 6,930th digit of pi is where that started, I think.
Amazing. So can you export any of this audio to import into a DAW, say?
I don't think so. I've been playing around with using these various audio loopback gizmos that you can hook up to kind of capture the audio of one app and send it to a file. But yeah, it's and this is all in the browser. This is just kind of freaking amazing that this all just lives in the browser. You can do full audio synthesis and music synthesis and song synthesis using pi. I don't even know what's going on. It's amazing. All right. So anyway, what's yours next thing?
I love mechanical keyboards. I have been using a mechanical keyboard for about 20 years, probably, going back to a local company that made clones of the original IBM XT, like that 20-pound keyboard. I just love them, but I've never built a keyboard. But that might be changing.
Ooh.
Thomas Pohl, who goes by THPoll2 on Twitter, has a coffee page, and we'll link to all of this, but he's built a split keyboard that's RP2040 powered. What's magical about it is every key has an OLED screen, so they're all customizable.
Wow.
Exactly. And he's walking through the build process on his coffee page, which is his blog, which is great. So he shares, there's a matrix of which keycaps and key switches may or may not work, because you've got to insert those little OLED screens, and they have a little ribbon cable that needs to come out of them. So if this works, I would be so excited to see something like that, not just on a keyboard, but more importantly on a macro pad. That's where I could see a lot of use for it.
Yeah.
One of the really neat things that he goes through on his blog is all the competitors that have tried to come out over the last 5 or 6 years, and none of them have really stuck around. Most of them, like Elgato with their Stream Deck, it's one RGB screen that they just segment off the little parts.
Yep.
Those keys aren't individual screens.
Yeah.
So, some of the use cases for that are pretty cool, whether it's different languages or whether it's a macro pad and you have different shortcuts for different apps. But it's really neat that he's walking through that whole build process, and comparing it to other keyboards out there, and comparing the key switches and the keycaps and everything that you're going to need to actually go with it. So it's something that it's not finished yet. He's actively working on it. He wants to make a kit, it sounds like, of it. Yeah. It's definitely something I'm going to be keeping my eye on, because once a maker can do it, some of those other companies might step in, and it'll be interesting to see if that's something that will ever be mass produced.
Yeah, I'm really interested in this. There's long ago there was a keyboard created by someone in Eastern Europe. Like it was a design agency, and it was called the Optimus or something. I forget the name, but it promised a display per key. And when they finally did release something, I think it wasn't display per key. It was maybe display per key for the function keys, and it cost $1,000. And it just was like, they kept having to sort of roll back their promises as they found out that it was really hard. And then the other thing I've seen is a couple people have tried making little OLED as keyboard keys, macro pads, where they just take these little cheap, tiny OLEDs that are I2C based and sticking them on top of a tact switch, and then kind of having there's enough flex in that connection system that you could flex the OLED and push the tact switch underneath it. But the problem with that is that you're flexing this circuit board that's not made to be flexed. you're pushing on an OLED piece of glass that's not made to be pushed on. And yeah, so of course, everyone, when they build these after like a month or two, was like, oh, it's starting to flake out. It's not working. Whereas this project, it seems like he's taking care. He's actually running the flexible circuitry cable from the OLED instead of using the, fixed PCB connectors. He's putting the OLEDs underneath the plastic keycaps rather than just having them be glass on the top. So it seems like he's actually thinking about the problem in a durable way rather than just like, oh, let's hack it together.
Exactly. And it's RP2040 powered, and I think he mentions KMK at some point as well too.
Oh yes, that would be the thing to do, wouldn't it?
It's amazing. I'm really excited about that, and if it ever gets to that kit stage, I'll have to give it serious consideration. But I have a feeling it won't be cheap.
No doubt. Yeah. Each of those little OLEDs, a couple bucks each, right? At least.
It adds up quick. That's why I'm kind of hoping for a macro pad. My macro pad is one of my two favorite CircuitPython powered devices. Mm-hmm. It's probably the one that gets the most used. I actually maintain an awesome list for the Adafruit macro pad. I love it so much. So if I can get OLEDs on that, because then I don't have to look at the screen all the time. Yeah. It would just be wonderful. I would be over the moon.
Yeah, I did end up getting some of those keycaps that have the removable plastic bit with a little piece of paper you can stick inside. So I could then label it. So I go, okay, this key is for launching this app and this key is for doing that thing. Yeah. It's like, oh, it'd be much better if I could just like tell it to update the keys themselves because they're all displays.
Right. What do you have for us next?
All right, so let's see here. To continue the audio trend and the machine learning trend, there's this new thing created by Aphex Twin, who's a artist, techno ambient artist who's been around for about 30 years or so, and David Griffiths. It's called Samplebrain. And so Aphex Twin, his real name is Richard D. James. He's been creating some weird, fun, sometimes disturbing music. It's very challenging. It's very interesting and very challenging to listen to some of his stuff. But he's been a Super Collider user kind of since Super Collider came out. And some of his albums, I think, have been mostly like almost exclusively Super Collider. You could do things that you just wasn't possible with synthesizers and effects in the early 2000s, but you could write a program to do it. And there's this really good engineer named David Griffiths that he has essentially worked with to create this thing that takes a target sample and using a collection of other WAV files, try to recreate that sample using those WAV files. And it uses some machine learning techniques to do this. It mostly just sounds terrible and awesome at the same time. And so here's a quick little sample of it.
Yes, that is definitely terrible and awesome at the same time.
This is the chip shortage song from Adafruit. So it's trying. It's trying hard to recreate it. Like a lot of these machine learning things, it depends on the library of information it has at its disposal. And I've not given it very much, which is why it's kind of janky. But with the jankiness, it's still interesting sonically. And so you could take these raw sounds and then do something further with them. It's free to download. You just go to the website and download it. There'll be a link in the show note. It's pretty weird, but it's been a fun thing to play with here now. Now and again, it's got can I throw these samples at it, and does it change what I'm getting out from the audio?
So we have Dall-E and Stable Diffusion for images, and now we have this for music.
Yeah.
I welcome our AI overlords.
Right. All right. What's your final thing?
I wanted to highlight a maker, Kevin McAleer. He has an amazing YouTube channel. He's got 40 different playlists with multiple videos in each playlist, and he's got a focus on building robots with MicroPython. The project that caught my eye recently, though, was he built what he called the Pikon, a take on Nikon with the Raspberry Pi high-quality camera.
Oh, interesting.
What's really cool about Kevin is he does an hour-long live stream where he goes deep. And so you're making a bit of a time commitment, but you can scrub through it. I would rather have a long video than leaving stuff out where if I tried to build it, it might get stuck, for example. Mm-hmm. But when he's building the video, he takes you through the camera itself. He teaches you about lenses. I picked up a couple things that I didn't know. He talks about computer vision and why this will work and why computer vision isn't important for this project. And he takes you through how he 3D printed and designed it and then assembled it. And it is just cool to see this 3D printed high quality camera in action.
I'm looking at the list of the videos he's created, and like, oh, here's an air quality sensor. Here's a robot. Here's some hackable glasses. It's there's a lot of really cool stuff here.
He's got a series on building your own personal AI.
This is great. And props for him for doing live stream builds. I have a really hard time having people watch me create stuff, and the fact that he's able to do that and it's usable. It's usable to other people. That's wonderful.
Yep, every Sunday, and I actually reached out to him too to have him on the CircuitPython show. He's done so much stuff with microcontrollers. He'd be a perfect guest. So,
definitely, yeah.
It looks like we might be able to do that in a couple months. I'm pretty excited.
Cool.
So, Todd, when you're not doing the podcast, what projects have you been working on lately?
As you might have known, I've done Eurorack modular synthesizer projects in the past, and one of the YouTubers / bloggers that I've been really inspired by is this person named Hagiwo. He's a Japanese. His YouTube channel and blog are wonderful resources if you want to build really inexpensive Eurorack modules, which is great because Eurorack stuff can get pretty expensive. But one of the things he's created, I think a couple of years ago, is this he calls the additive VCO, and he uses an Arduino Nano and a handful of passive parts and a single op amp to create this beautiful, like interesting sine wave summation thing. Here's a little audio sample of it. So it's really simple. All of his stuff he does by hand soldering on perf board. So this last week I've decided to lay it out on a PCB and maybe get the PCBs made using all through-hole components so that maybe anyone could make one of these in like an afternoon. Because doing stuff by hand on perf board requires a bit of skill. He's very good at it. I can do it. I'd much rather have a PCB. It's much easier. But
I can't do it. I want to learn so bad, but I just can't. My soldering skills are not there.
No, it's like PCB is the way to go. And this project is a really good example of how to use the Mozzie audio library. It's this audio synthesis library for Arduino that I've used a bunch. And the whole code for it is just like maybe like 30 or 40 lines. It's like super simple, pretty understandable. So I think it's a good sort of thing to explore further. Like, hey, I can make this cheap little Arduino Nano based Eurorack module. So that's what I've been working on this week.
Very cool.
And what have you been up to?
I took the CircuitPython show on the road recently and traveled 2 hours east to Wisconsin for a very special Halloween episode that's going to be coming out in just a couple of weeks.
Oh, that's incredible. Is it spooky?
It involves a couple of trolls, and and we're not talking internet trolls. We'll leave it at that.
That's awesome.
But other than that, I had Braden Lane recently on the show, whose CircuitPython projects, including he's got a macro pad called the Joypad, and then he's got some LED projects called the Loomis Ring and the Loomis Stick that I think are just super cool. It was great having him on the show.
Yeah, the Loomis Stick is cool.
Yeah. And coming up is Jim Musared from the MicroPython project.
Oh, interesting.
Yes, a lot of people might think that MicroPython and CircuitPython, being a fork, might not get along, and it couldn't be farther from the truth. We had a wonderful conversation.
Wait, so there's no fight? I want to see a fight.
No fighting. Lots of hugging.
Aw.
Well, that's all we have for you this week. Thank you for listening to The Bootloader. For show notes and transcripts, visit thebootloader.net or follow us on Twitter @thebootloader. Until next time.
Bye.